Now let's have a look at question 9. Question 9, it was a cubic function given in the figure shown, as you can see there. And then therefore the question says the function of f of x is equals to 2x cubed plus px squared plus qx plus 3. All right, so basically that's what they've given to us. And then they said that this is drawn below. This is the turning point here. So that gives us the turning point, and M is also the turning point as well. And therefore G, which is right here, they are saying that G is our y-intercept. A, we've got A, B, and C. These ones are our x-intercept. All right, so therefore we have got these points here, which is the turning points. All right, so let's go ahead and read on question number 1. Question number 1 is given by 9.1. It says here 9.1, show that P is equals to -5, and then Q is equal to -4. So what you do in this case, because we're only given these 2 points here, so you're gonna substitute n into our equation. All right, let's go ahead and do that. So in this equation, when x is equals to 2, y is equals to -9. So we're gonna go ahead and substitute that into this formula, into our given equation rather, plus px squared plus qx plus 3. All right, so therefore this will be -9 as given there. This will be 2 minus, no, not minus, rather it's what? It's -9 2 cube plus p 2 squared plus q 2 plus 3. All right, so we're going to simplify this. If we simplify this, we're going to have -9 there, and then this here 8 cube will give 2 cube will give us 8, and then 8 times 2 will give us 16, plus 2 squared will give us 4. 4 times p will give us 4p plus 2q plus 3. Therefore we'll take all the unknowns. We'll take 16 to that side, and therefore also 3 to that side. All right, so therefore at the end of the day we are going to have -28 is equals to 4p plus 2q. All right, when you get here, you've got 2 unknowns who are stuck. Therefore we're going to mark that one as equation number 1. But we know that in order to get the turning point when we're given a cubic function, we need to find the first derivative. So we're going to come here and say the first derivative, which is x prime. This is now to find the other equation here. So if we take the derivative of the given equation, we drop the 3 times 2 is going to give us 8 squared plus 4px, and then plus q, because you are derivating in terms of you are derivating in terms of x. All right, so after doing that, what you do now in this case, you get the turning point when the derivative is equals to 0. So we know that the turning point is given when x is equals to 2. So we're going to come here into our equation, then substitute x is equals to 2 here at the turning point, plus q is equals to 0. And then therefore if we simplify this further, can we simplify further? Yes, we can. Therefore we are going to take this one here, will give us what? 4 times 8 is going to give us 24, is going to be plus 8p, is it? Nope, I made a mistake here, guys. When I was taking the derivative here, I made a very terrible mistake. The derivative of 2x is going to give us 2 here, not 4. 2 times 2 gives us 4. I think that kind of makes sense now. It's equals to 0, because when you take the derivative of this, you're going to have 2px. Right, great stuff. So now let's move right along. Now we're going to take 24 to that side. Now we're going to be left with negative 24 is equal, not is equals to 0, but negative 24 is going to be our equation number 2. So now what do we do now? We need to solve simultaneously. So we're going to have negative 28 is equals to 4p plus 2p, which is our equation number 1. Therefore, equation number 2 given by negative 24 is equal to 4p again plus q. Okay, rather this is q, not p. This is q there, and then that's equation number 2. So what we can do here in this case, we can say equation number 2 minus equation number 1, or equation number 1 minus equation number 2. It doesn't matter. So let's just say 2 or 1 minus equation 2. So it's going to be negative 28. Okay, negative 28 minus 24. So the answer will be negative 4. And then you say 4p minus 4p is equals to 0, and then plus here 2q minus q, we're left with only 1q. Therefore it means q is equals to negative 4. Then we can substitute in either equation to find q. So let's use equation number 2. Then we're gonna substitute q into equation number 2. There you go. So now in this case, now we're just gonna come here, say negative 24 is equal to 4p negative 4. Then take 4 to the other side, is going to be negative 24 plus 4 is equals to 4p, which gives us negative 20 is equals to 4p. Then you divide everything by 4. In this case, p will be equals to negative 5. Okay, then you have successfully proven that p is equals to negative 5, and then q is equals to negative 4. 9.2 said determine the coordinates of g. All right, coordinates of g. What is g here? They did tell us g is y-intercept. So 9.2, or maybe let me just move to another page and then let's do this one on the next page, guys. Here we go. All right, 9.2 is going to be given by y. This is our y-intercept. Okay, so y-intercept, we get it when x is equal to 0. So on our given equation, everything will be 0 where there's x. So we're going to put 0 there, plus p 0 squared plus q, then 0 there, plus 3. Right, so therefore everything else will be 0. Therefore it means when x is equal to 0, y will be 3. Therefore the coordinates of g will be 0 is to 3. All right, 9.3 said if it is given that c, where c is here, c is given by 3 is to 0, calculate the distance of AB. So they want us to calculate this distance here. So basically they want us to find the other x-intercept. All right, so now we're gonna come to our equation. We already know what is q, so it means now our original equation will be given by 3x cubed, and then we know what is pp, it's minus 5x squared, q is minus 4x plus 3. So we already know one of the factors, they give them to us. We know one of the factors is what they give us, x minus 3. So therefore it means we're left with this side here is going to be x squared, so that we get that one. No, sorry, it's not going to be x squared, it's going to be 2x squared. Rather, it's going to be 2x squared. Right, great stuff. And then now we look for the middle term. Okay, Now we look for the last term, which is this one here. How are we gonna get this one? We have to say -3 times something here must give us, so it's gonna be -3 times -1 will give us +3. Great stuff. So now for the middle term, you are looking at, we are looking at something that will give us this, which is -4x here, right? When we multiply it with when we multiply together with this one here, which is x. All right, so what we do in this case, there's a way of factorizing this cubic function, guys. We have indicated that I'll put that description below, but here it's gonna be plus x. All right, and that's how you would deal with this one. So now here you would have -3, and then you're gonna factorize this here, and then you know that everything is gonna be equal to 0. So you're going to have 2x and then x here, then two numbers, when you multiply them together is going to be 1 and 1 there, and then you're gonna have +1 and -1 here. So therefore it means here x is equals to 3, which is at C, x is equals to half, and then x is equals to -1. So this half is here at B, this one here is this one, 3 is at C, and then this one is at A. So now in order for you to get the distance, we need to add this. So therefore it means the distance between A and B is going to be equals to 1.5 units. Remember that, guys, you don't consider the negative when you are dealing with the distance. You must just add those variables that we found. Okay, so guys, I didn't explain this properly here, but please take note. You can watch this on how to factorize a cubic function on this channel. I am Gaston Mapala. Let's move on to the next question, which is 9.4. All right, 9.4 said calculate the coordinates of M. M is the turning point. So therefore, in order for us to calculate this, we need to take the derivative of the equation. All right, 9.4, we got f of x given to us as 2x cubed minus 5px. No, not 5p, rather. We already find this one, minus 5x squared minus 4x plus 3. Therefore, what do we do when we're looking for the turning point? We take the first derivative and then we must equate the first derivative is equal to 0. So 3 times, oh, not 8 rather. What am I saying? 3 times 2 is going to be 6, and then we minus 1 from the top, so we're left with 2. 2 times -5 is going to give us -10. Minus 1 from the top, we're left with x. Drop 1, minus 4, and then that's how it is. Then we're gonna equate this, is gonna be equal to 0. Therefore, what do we do now? We can divide everything by 2 here, because we see that this is a multiples of 2. Divide everything by 2, so we're gonna be left with 3x squared minus 5x, and therefore minus 2 is equal to 0. So therefore we're gonna have to factorize this. Therefore we're gonna have 3x here, we're gonna have x there, and then we're gonna have 2 times 1 here, and then the answer needs to be negative, negative, positive. So x is equal to -1/3, and then x is equal to 2. Right, so therefore -1/3 will definitely be the coordinate of M. So therefore we're going to say M will be given by -1/3 here, -1/3 rather, -1/3. So now you are left with the y value. The y value, you need to go back to the original formula, then substitute -1/3. What did the question say? The question said only find the x coordinate, so therefore you are gonna leave it here. All right, so therefore 9.3. Guys, if you have questions, please leave them on the comment section below as we continue with this question. And then it says the 9.5 said determine the x coordinate of h, the point of inflation. So point of inflation, you found it when the second derivative of a function is equals to 0. So we already have the first derivative there. So what we can do, we can continue from the first derivative was given by this, remember? It was given by x squared minus 10x minus 4, and then therefore you need to take the second derivative, is equals to 12x minus 10 is equal to 0. Therefore we need to solve for x here because they are requiring us to find the x coordinate. So guys, because you guys are in grade 12, I'm already doing this straight away. There you go. So x coordinate will be 5/6, right? And that was 9.5. Let's move on to 9.6. 9.6 says for which values of x will the curve be concave up? 9.6 is going to be for which values of x is the graph concave up. So starting from the point of inflection, which is here, going all the way, this graph is concaved up. Then starting from here, no, not the other way around, sorry guys, that's concave down. Starting from here, starting from there, going up. Let's just see, where are we now? Okay, we are on point H there. Starting from here, yes, I'm right, it's going all the way like that, is concaving up. So for all the values that are greater than 5/6, the graph is going to be concaved up. All right, and that's how you would deal with a question like this one, guys. And therefore 9.7, just look, concave, this is concave up, that's concave down. So you just look at your curve from the point of inflection, going there is concave up, then from here going all the way like that is concave down. So this will be up, and therefore this would be down. All right, so now 9.7 says for which values of x is f times x multiplied by f of x prime less than 0. All right, so I can say that to you from here, this turning point going all the way like that, this graph has got a positive gradient, so therefore it means it's increasing, therefore this graph is greater than 0. Right, so now from here going down, this has got a negative gradient here, so it means the graph is what is decreasing. Then from here going all the way like that up until this turning point here, this graph is what? It's also increasing, therefore this graph is greater than 0. So now let's move right along and see on this graph where is, when you multiply the function and also its gradient, you get a positive number. All right, number on this, guys, when you are above the x-axis you are positive, when you're below you are also negative. So now let's go ahead and look at this one. If you have a look at this one, the point here, point A, here what do you have? You've got -1, and then here is half, and then here I think it was 3. So basically here what you are looking at, you are looking at the intercept and also the turning point. All right, so now when x is less than 1, will you have a negative value? Yes, you will have a negative value. Here the gradient is positive, and then the function is below what is below the x-axis, so therefore you would have a negative. So therefore for all the values, where are we? For all the values where x is less than a -1, this will be true. Now let's move on to this turning point. When you are at this turning point, what do you have? You've got a positive gradient, but you also have a positive. So for this one, it's not going to hold. And therefore, when you're here at 2, guys, if you don't understand what I'm talking about here in this case, please go and look at our series 4, where we explain into detail how do you look at for these values of x and whatnot. I'm going to leave that description of that video in the link below, or just Google on this channel, write for which values of x, then you will find those videos. There's about 4 videos there that explain this thoroughly into detail. Right here, I'm only focusing on the solution of this question. All right, so therefore now we just have to look at this one here. When you are sitting here at B, what do you have? What you're sitting here at B, what you have, you've got a negative gradient, and then the function is what? It's above. So therefore, for all the values that are less than, but these values need to be greater than. So for all the values of x that are less than half, but also have to be greater than -1/3. So it basically means, actually, let me just use a different color here, guys, so that I don't confuse you. It basically means this is what you are looking at now. It basically means now what you're looking at, you're looking only at this portion from this turning point up until here. What do you have? You've got a negative gradient. The function is above the x-axis, so the function is the positive, the gradient is negative. So that gives you what? A value that is less than. So therefore that would be correct again. When you come here again, you look at this part here. I can see my cursor. If you look at from here up until this point here, what do you have? You have a positive gradient here. The graph is going up, okay, but the function is below the x-axis, so therefore you have got a positive gradient but a negative function. So you've got what? A positive gradient, negative function. This gives you what? Something that is less than 0. So therefore what would you do? Would you say for all the values that are greater than 2, but these values also have to be less than 3. And this would be all your values in this case. All right, and let me see you on the next upload, guys, where we'll be doing question 10, which is the last question on this paper. If you don't understand, please let me know. Leave a comment. I will do my best. We will do more videos specifically focusing on what you don't understand.